Alright, so we're going to graph the rational function. How do we find domain?
Set your denominator not equal to 0.
Good. Denominator not equal to 0. So I'm going to have to come down here at the bottom. And so I'm going to show I'm working on my domain. My denominator is what?
X plus 1.
A squared minus 1 cannot equal 0. Which, what can we do with that? You can factor it. So it's x.
Plus 1 and x minus 1.
Good, because it was a difference of squares. And what do we do?
Not equal to 0.
Set them both not equal to 0. And so we get x cannot equal,
-1.
and x cannot equal.
1.
So how do I write my domain? Union, -1 to 1, good. Very good. Y'all don't forget that part. I'm noticing some of the quizzes, y'all stop at that x is not equal to -1 and x is not equal to 1. That's good for the work, but I want the answer in interval notation. Alright, so next we're going to find the, let's go ahead and go to vertical asymptote, because I'm going to keep in the order that we did it in our notes. How do you find the vertical asymptote?
You said the bottom equal to 0.
Not quite. Help me, help him. The uncancelled factors of the denominator of the bottom equal to 0, okay? So uncancelled denominator equal to 0. So that means we're going to have to look at factoring this, right? Well, the top's already factored for me. So how do you factor the bottom? That's that difference of squares. We just did it when we found the domain, didn't we? Does anything cancel?
Yes, it does.
The x minus 1, right? So what is my uncancelled factor in the denominator?
X plus 1.
So we're going to set it equal to 0.
Which I'm going to take
And so we find a vertical asymptote at x equals -1. Okay, the next thing we did was our holes. How do we find holes?
What doesn't cancel.
It's what does cancel. So it's canceled. I'm just going to abbreviate canceled factors of the denominator equal to 0. And remember, this is going to be an ordered pair, right? So once you get that x value, you have to plug it in to solve for the y. Alright, so for holes, did I have anything cancel?
And then -1, x minus 1.
The x minus 1. So set it equal to 0. And we get x equals 1. But remember, a hole is an ordered pair, so it's going to be 1 comma some y value. How do you find that y value?
You plug it in back to the original page.
Plug x back into the simplified equation. So your simplified equation is the x minus 2 times x plus 3 over x plus 1. Now plug x as 1 in there. And simplify that. And so you find you have a hole at 1, -2. Alright, so next we did horizontal asymptote. How do you find the horizontal asymptote? What do we look for? Highest power of x. Good. So we're looking for that largest exponent. So on this one, where's my largest exponent going to be, on top or on bottom? Well, be careful, because if I took these two things here, I have to multiply them out. What's x times x?
X squared.
X squared. Let's go ahead and multiply those out to see what we get. So we get, I'll just do it going across. So we got, you said x squared, and then x times 3, -2 times x, and -2 times, went too far there, -2 times 3 over your x plus 1. No, it's x plus 1 because the other one canceled, remember? So we get x squared plus x minus 6 over x plus 1. So now tell me again, where's my highest power of x? It's on top. What is it if it's on top? Good. Remember we use the no, and top means none. What does the bottom mean? Y equals 0. What if it was both of them? The ratio of their coefficients. Good. Alright, so my horizontal asymptote is none. Alright, so then we're going to find slant asymptote. How do we know if we have a slant asymptote? Say it again. Alright, so slant asymptote. Again, how do we find out if we have one?
Long division.
But how do we know if we need to do the long division? Because we know it's going to have a slant, but how do I know if I give you one tomorrow? Maybe I'll trick you and just give you one and tell you to graph it and it doesn't have a slant.
You wouldn't do that because you're a sweet woman.
Oh, I could do that.
It either has a slant or a horizontal asymptote.
It won't have a slant and a horizontal, so since we have no horizontal, there's a very good chance we have a slant. But what guarantees there's a slant? The degree of the numerator has to be greater than the denominator by 1.
Okay, hold on.
What's the degree of the numerator?
2.
What's the degree of the denominator?
1.
So the top is bigger than the bottom. Is it by 1? Yes, so we have a slant asymptote. And how do we find a slant asymptote? Long division.
Is the degree exponents?
Yes, degree is exponents. Alright, so we already did, you have to have it in polynomial form in order to do slant asymptote. So looky there, and it worked for us twice. I'm sorry, I circled the wrong one. It's this one, because we want the simplified one. So remember, what's on bottom goes on the outside. What's on top goes on the inside. Make sure your exponents are in descending order, and make sure every one of them is accounted for, guys. If we did not have an x, then we would have to put a 0x there in the place. Now let's divide. What's x squared divided by x? And multiply that to all. So x times x plus 1. Good, distribute. Subtract, so we're going to change the signs. So it cancels. Oh, what's x minus x? It also cancels. So we don't have anything there, so then just bring down the rest. Can I keep going? No, normally we would have something right here, right? And then we would be able to keep going because it would be an x. But we don't have that, so this is my remainder. And what do we do with the remainder on a slant asymptote? We don't worry about remainder on slant asymptote. So I'm going to write y equals, and whatever I have on top there is my answer. So my slant asymptote is y equals x.
Before you started this, you said to find out if you have a slant, you look at what?
All right, x-intercept. How do you find your x-intercept? Good, your numerator is equal to 0. So I'm going to come over here on the left. So my x-intercept. Well, what's my numerator? Well, we can say it's the x squared plus x minus 6. Or we can go back to the factored form, and it's the x minus 2 times x plus 3. I'm going to use the factored form because we're setting it equal to 0. If I use the trinomial, I'm going to have to factor it anyways. So it really doesn't matter. We'll get the same thing. So x minus 2 times x plus 3 equals 0. Set them individually equal to 0 and solve. So we have an x-intercept at 2, 0 and at negative 3, 0. Okay, y-intercept, how do we find that? X equals 0, solve for y, right? Alright, now it doesn't matter if you use a polynomial form or you use the factored form at the beginning. Excuse me, so for my y-intercept, I'm going to use the polynomial form because it's just easier to me. So it was x squared plus x minus 6 over x plus 1. And what are we plugging in for x? 0. 0 squared and 0 cancels. So I have negative 6 on top. And then 0 here cancels. So I get 1 on bottom, which is, so I have a y-intercept as 0, negative 6. Alright, so I cleaned it up and we drew in our x and our y-axis. My lines are going to be by ones. If I wanted them to be anything different, we would have to definitely label it. So let's go through it. Remember, you don't graph the domain, but you're going to graph your vertical asymptote at x equals negative 1. So go to where x is negative 1. And remember, x is negative 1 all the way up and down that line. If you pick any point on this line here, it's negative 1 comma some number. Okay, that's that vertical asymptote. Alright, then we have, next thing we had in our list is I have a hole at 1, negative 2. So 1, negative 2. Remember, a hole is an open circle. We don't have a horizontal asymptote, so we don't have to worry about graphing it. But we do have a slant asymptote. And that slant asymptote, remember, is y equals x. So how do I graph the line y equals x? Well, it's always going to be linear, so you're just going to use your slope and your y-intercept. On this one, what is my slope?
1.
And we're going to write it as a fraction, so we're going to put it over 1. Good, so 1 over 1. What does that tell me I'm going to do? Up 1 and right 1. Or if I can't go up, I could go down 1 and left 1. And what is my y-intercept? Remember, y-intercept is your starting point. No. For this equation, guys, yeah, I see where y'all got the negative 6. It's not negative 6. For this equation right here, what is that y-intercept? Well, it's going to be plus what number there? Is there one? There's not a number there, is there? So what number could I add to it that won't change it? 0, okay? So your y-intercept for your slant asymptote is at 0. So to graph it, go to 0, 0, your y-intercept, and then up 1, right 1. And so I'm I started out with dots, but remember this is your slant asymptote, so it needs to be dashes anyway, so I just kind of switched it up there. And I went all the way, it's quite a ways there. And then down 1, left 1. You want your slant asymptote, guys, to reach all the way across your graph there. So then after the slant asymptote, we're going to graph our x-intercepts. We got 2 of them. One at 2, 0, and one at negative 3. And then we got our y-intercept at 0, negative 6. Now, what about those extra points? What were we supposed to do there? Remember? We need our table, don't we? So let's make that table. So we've got our interval, an x value, y value, and the sign. Now hopefully on this one, I'm going to kind of skip over the table right this second. Can you see your graph up there? Hopefully you see the right side of it, because you can play connect the dot, right? And you're shaped by those asymptotes. Now watch this on that slant asymptote. It just goes up there towards it, but it's not going to cross it, okay? Now the other side, you do have a point there, so you can go ahead and use that. Remember, you're shaped by those asymptotes. But sometimes we don't have those extra points already there to help us shape it. So make sure you make that interval table there. Remember, your interval is formed by your x-intercepts and your vertical asymptotes. So on this one, you would have, what, negative infinity to negative 3, negative 3 to negative 1, -1 to 2, and then 2 to infinity. And you would pick some values in here. And then you get their y value, which I don't know what they are off the top of my head. I know this one's going to be negative, this one's positive, and it's going to be negative and then positive when you get down, okay? Most of the time, these will alternate. Okay, if they don't alternate, question why. Sometimes it's because it's an x-intercept that has multiplicity of an even number, okay? Usually that's the only time that you'll have it where it's like positive, positive, or negative, negative. So always question if they don't alternate, why don't they alternate?